Okay, so this one says Algebra 1, Semester 2. It's the first unit in the second semester called Exponents, and it's the third lesson in the unit Exponents, and it's called Special Products of Polynomials Practice. Find it on creatormath.com under the Algebra tab. Scroll down to find that unit and that lesson. Here are the directions. Copy the following problems into your composition book on the correct pages, according to the table of contents, with the notes for those pages. Don't forget the notes. That's on the table of contents prior to these problems and to this video. This is all from creatormath.com, and this one's under the Algebra tab. So to start this lesson, let's talk about CLT. CLT stands for combined like terms. And remember, on my multiple choice answers, the right answer always pops up on top. On yours, it's going to be in random order, just so you know. CLT, combined like terms, is the concept that in math we can join together terms of the similar properties. And when we say combine, we're almost talking about adding and subtracting. So add and subtract. And to give us some background on that, one of the first ones they give us right here is x squared plus x cubed. And notice the caret right there, right? That's shift 6. Shift 6. If you're typing in a power or an exponent on Google, you're going to need to use the shift 6 key to do it. Well, I call it a caret. In English, they use it to say insert something here, right? I think that's what it looks like to me. Well, so when we write this, it looks more like this, x squared, and there's a plus on this, x cubed. The interesting thing about adding or combining like terms, it has to do with add and subtract. This is being added. We have an x. Both of these are called bases, right? This is the base. X and x are the same. That's good news for us. That looks good. However, these powers need to be the same also. So this is a power 2. This is a power 3. They are different. So these are not like terms. These two cannot be added any more than they already are. So the answer to this is x squared plus x cubed is x squared plus x cubed. You can't do anything else with it. So it's somewhat of a trick question. They're kind of inviting us to break the rules to sort of test whether we know what like terms are or not. Now, they contrast this by giving us a problem right below it. The problem right below it is a multiplication problem. This one is x squared times x cubed. This is not a combined like term situation, and this is what confuses students so much in algebra. They're like, well, wait a minute, what's the big difference, right? Addition and subtraction versus multiplication. Well, I know it's hard to understand sometimes, but math is all about details. The difference between these two is completely different. We can totally multiply x squared and x cubed. It looks like this. There's an x to the 1, x to the 1. That's x squared, right? X times x is x squared. And x cubed is 1, 2, 3, all to the 1 power. And of course, we don't show 1 powers, right? There's 3 invisible 1s. On an x, there's an invisible power 1. There's an invisible multiply by 1, and invisible divide by 1. But if it's 5, it's 5 to the 1, 1 times, and 1 below. It's the 3 invisible 1 rule, right? There's always 3 there. We don't show them. We just write x. We know there's 3 around it. We just write 5, right? We don't write 5 to the 1 times 1 divided by 1. That'd be a lot of work. We're lazy. We want to abbreviate. All right, so anyway, there's 2 x's and 3 x's as in the form of x squared and x to the power 3. 1, 2, 3, 4, 5. This equals x to the 5th. And what's really happening, some students will be like, wait, I didn't have to do all that work. I could have just, if I had noticed this, was x 2 plus 3 right here, which is x to the 5th. And that's what they're getting at. So they say x to the power 2 plus 3 is what they're doing. And that's how they write it. Remember the caret, the parentheses says this gets added. It actually looks like this. So just adjust your brain to be able to translate those kind of issues. Okay. Now let's move to FOIL. FOIL is a uniquely American phenomenon. FOIL stands for first, outside, inside, last. This can cause some trouble unless you know what it applies to. It applies to the multiplying of 2 binomials. Let's say we have an x plus 2. Let's say we have an x minus 3. All right, this is called a binomial. Why? Because bi means 2, and so it's a 2-term expression. 1, 2, and it's 2 binomials multiplied. So a binomial times a binomial, and it produces what we call a quadratic. A quadratic requires 4 multiplication steps, and what they do is draw a figurative center line right down the center of these two binomials. And then they proceed to split this up into FOIL, which stands for first. The two x's are the two first terms, f. Outside, the -3 and the x are the furthest outside terms from the center line. Okay, I don't know how else to say outside, but there's an imaginary center line, and these two are outside. If those are outside, then the 2 and the x are inside. So this is the O, this is the I, and then this 2 and this -3 are the last terms of the two binomials, so they say last, right? So what do you have? You have the first term, which is x squared, the outside term, which is -3 times x minus 3x, the inside term, which is 2 times x plus 2x, and the last terms, which is -3 times 2, which is -6. And then notice we are now adding. These two have the power 1, so they can be combined. So what confuses students most is this started as a multiplication problem. Now it turned into an addition problem. So the rules for combining these terms change. Now we're down to CLT. Now we're down to combine like terms. So they're like, wait a second, what's going on here? Well, in this case, the -3x plus 2x leaves you with -1x. There's still an x squared on here, and there's a -6. And now notice we are left with a 3-term expression, or a trinomial. 1, 2, 3. Each one of those is a term. They give us a problem here. They're starting to warm us up on this whole idea. This is x plus 3, and this is squared. Well, this equals an x plus 3 times an x plus 3. That's anything squared or to the power 2 means 2 of these items multiplied. There they are, 1 and 2. So they want us to circle this one right here, and they're prepping us to do the FOIL method. The alternative to the FOIL method is the distributive property, and I'm a big fan of the distributive property, but for some reason we teach our kids this FOIL thing, and we love it, and so students show up going, I learned FOIL, and so I teach FOIL too, you guys. So now we have x plus 3 and x plus 3. Let me write it out a little bit bigger and clear. All right. We're going to do first, outside, inside, and last. First, x times x is x squared. Outside, 3 times x plus 3x. Inside, 3 times x plus 3x. Last, 3 times 3 is 9. Combine like terms. Why can you combine them? Because it has the same base, an x and an x, and it has the same power, 1 and 1. Right? So a 3x and a 3x, 6x, the 9 stays what it is and comes on with it. Can't drop it. The x squared stays there and comes with it. This is positive because it was 2 positives added. And so they're looking for several answers here. They're looking for an intermediate answer here, x squared plus 3x plus 3x plus 9. And they're looking for us to combine like terms here and go to this answer here. I'm doing it in 2 steps. They're doing it in 2 steps. They're trying to walk us through in this idea that they're leading us down through the different steps of the problem. I guess maybe they are. Maybe they're not. I don't know. So this one is hard to see, but it says x plus 3 times x minus 3. We're going to do first, outside, inside, last. First would be first would be x times x, because remember there's a center line down the middle. So that's the first term, and that's the first term. X times x is x squared. Then they go to outside, -3 times x is minus 3x. Then they go to inside, plus 3x. And then they go to last. Plus 3 times a minus 3 is a minus 9. We also can combine like terms here. We also can combine like terms, but look at this. A -3x and a -3x cancels. It goes to 0, right? These disappear. The x squared is left and the minus 9 is here. And this is an interesting case. And notice it happened when we had different signs but the same value as the second term of the binomial. So let's clean up our answers here. This is this one. They wanted an intermediate step. This is this one. They wanted the final step. And then they're going to start with another one here. And looks like they're going to go to the intermediate step here. Notice that -4x and 4x are going to cancel out, right? And notice that the signs are different. So an x plus a 4. times an x minus a 4. And that's what, incidentally, the name of this lesson is Special Products of Polynomials. By the way, a polynomial just means a multi-term expression. So this is a trinomial, 1, 2, 3, but you could also call it a polynomial because it's 2 or more terms, right? And the interesting thing, special products, is the idea that it's cool to us math people that these like terms cancel out and the term disappears and we're left with this shrunken answer, so to speak. We like that. That's so cool to us, right? So that's why math people love these kind of problems where you'll see a positive and a negative and the same value as the second term of the binomials, because eventually they're going to cancel out. Well, let's do first, outside, inside, last. X times x is x squared. Negative 4 times x is negative 4x. 4 times x is 4x. And 4 times a negative 4 is a negative 16. But there, those two interior terms, both are like terms, and both are being combined now, added or subtracted, right? Because there's a minus here. A 4x minus 4x, 0, they disappear, and you're left with x squared minus 16. Ooh, cool. That's that special product of polynomials where we think it's cool. We're multiplying two polynomials here, or two binomials in this case, using the FOIL method. It's 4 steps, and it produces what's called a quadratic. Just so you know, he'll start to do quadratic equations, right? And it's anything in x with the power 2. And why is it a quadratic? And I always wondered that when I was a student in high school. I'd be like, why is it called a quadratic? I don't see any 4 going on there. That's a 2. X to the power 2 is a quadratic. The reason is because 4 multiplication steps are required to produce it. And so there you go. So here's the intermediate step. We're circling this answer. They didn't seem to give us another one at this answer. I'm not sure why they didn't give us a problem there. When I say they, I wrote it. So they being me. I don't know why I didn't put one in there. So this says x plus 6 squared, right? That just means x plus 6 times x plus 6. We're going to do first, outside, inside, and last, FOIL. X times x is x squared. Outside is plus 6x. Inside is plus 6x. And last is plus 6 times 6 is 36. Now when these combine, they go to 12x in here. X squared plus 12x plus 36. Interestingly enough, so here's this one here. That's that answer. Do they continue on with the 12x over here? No, they give us another one here. They give us one right here, x plus 6, x plus 6. Let's do that, okay. And first, outside, inside, last is x squared plus 6x plus 6x. Didn't I just do this one? Plus 36. There's 12 in there twice. Oh, because they wanted us to explore the idea that we had it raised to the power 2, therefore it produces 2 of them. Good. Now we know that it produces this right here, right? And we went to the next step already and said that this was x squared plus 12x plus 36 because we combined the two like terms, and that's producing this answer here. There you go. It all makes sense now. One or two more. Two more. This one is a positive and a negative. We can expect the middle term to disappear. So notice how this one has a minus 5x and a plus 5x. That's going to disappear and drop all the way down. I can already tell what the answer is here. X squared minus 25. And I can tell that this is the intermediate step. Here's what the math looks like. Okay, first, outside, inside, last, FOIL. X times x is x squared. Outside is minus 5x, inside is plus 5x, and minus 25. And that's this one here. And we see that these now disappear. They cancel because a plus 5x minus a 5x is 0, but you're still left with the x squared minus 25, and that's this here. And lest I be remiss, you know, most math training in countries outside of the U.S. doesn't know about this and doesn't like and does not appreciate this FOIL method. They just like distributive property, which I do too. I think it makes sense. If you teach distributive, then why have a separate method where kids are like, well, use FOIL on that one, but you use distributive on this one? No, it's distributive property. And what we do is split this apart. We take x here from the first part and multiply it by x minus 5 the second. And we add to that the 5, and we multiply that by the second again. Okay, take one of the first and the second of the first, and this would be splitting this up into a distributive property problem. Here we get x squared minus 5x. Here we get 5x minus 25. And sure enough, negative 5x and positive 5x are gone, right? X squared minus 25. This would be what it looks like if you're learning the distributive property, and I like it just as much, but we're obsessed with this FOIL thing, so on we go. Remember, you're finding this assignment on creatormath.com. You're doing the other assignment where you fill out the multiple choice questions, and you're putting these in your notes in your composition book according to the table of contents under the Algebra tab.